website anytime you want. I'll post the link on my recent documents on the website so that you can click it, because when you go to the video or the notes, you won't be able to click it. So you can access it, and then you're just responsible for knowing the quadratic formula. You can teach it to all your friends if they have a terrible teacher who doesn't sing for them, those types of things. Okay. Now, the next thing that we're going to do is, you don't have to write anything down for this. I am showing you where the quadratic formula comes from, because that's a lot of variables all squished with a bunch of different mathematical operations, and some mathematician just didn't pull that out of nowhere and say, here's a formula that solves quadratics, right? Okay, it actually is completing the square. So here is all my work for the equation 0 equals ax squared plus bx plus c. And I completed the square with no numbers. And I worked it out, and in the very end, my answer is the quadratic formula. Okay? You will never have to do that. That's like a proof of the quadratic formula. You'll never have to reproduce that for me. But we all need to be okay with the idea, the quadratic formula comes from something, right? All math formulas do. And that completing the square is the math behind the formula. Which is actually really cool. And someday, when you get maybe into college and you take a college algebra class, they might show you the whole proof of the quadratic formula. But most of the time, and if you want to see it, you could come see me before after school. Most of the time, I'll get probably 75% of people just staring at me. Kind of lost. But it comes from something, which is actually really cool. Okay, now, this you want to write in your notes. This is called the discriminant. Discriminant is a part of the formula, and it's the part of the formula that's underneath the radical. The radical is the square root. So when you look back at the quadratic formula that you had written down, underneath the square root you have this b squared minus 4ac. Now, that's called the discriminant. We are going to make up a notation, and I'm going to use this red triangle to represent the discriminant. This is not official math notation. Okay, so you could make anything you want for that red triangle. If you wanted your discriminant to be equal to a happy face, and have happy face equal to b squared minus 4ac, you could do that. If you wanted to use a letter instead of a shape and call it d equals b squared minus 4ac, d for discriminant, you could do that as well. Okay. I'll show you in a little bit. This is inspired by Peppa Pig. Does anybody have any young siblings who might watch Peppa Pig? Okay, so there are a few people in the room who know, or maybe they watch it themselves, I'm not sure, who know about Peppa Pig. And I didn't know about Peppa Pig, but Mrs. Hahn told me about Peppa Pig, and this Peppa Pig's dad, Daddy Pig, apparently works with numbers, and this is in his office, and I'll show you that clip too. So we're using Peppa Pig notation as opposed to official notation. Okay. So red triangle is b squared minus 4ac. Now, a few things that you should know. If your discriminant is positive, you will have two real solutions to the quadratic formula. Those solutions can be nice numbers, they can be fractions or decimals, they could be irrational, so they might have a square root of 6, which you can't simplify. The key here is they're real, so they won't have the square root of a negative number, because the discriminant is positive, and so you won't have any i's if your discriminant is positive. If the discriminant is equal to 0, then instead of having two real solutions, you'll have only one real solution. And if you're thinking about the quadratic formula, you're taking the square root of the discriminant. If you take the square root of 0, the only answer is 0, and then it's supposed to be plus or minus 0. Well, 0 isn't positive or negative. So instead of getting two separate answers, you'll only get one. And you saw examples like this, sometimes if you were factoring, if it was a perfect square trinomial and your two factors were the same, when you set those two factors equal to 0, you get the same answer twice. That's called a double root. And the last possibility for your discriminant is your discriminant could be negative. Now, if your discriminant is negative, that means you're trying to take the square root of a negative number, and we have discussed this about a week ago. Square roots of negative numbers are not real, they are imaginary. So when you do the square root of a negative number, or your discriminant comes out to be negative, you'll have two imaginary solutions. When you give me two imaginary solutions, I should see the I in them. So we'll look at an example first before we do the actual quadratic formula of just finding the discriminant and determining what type and how many of solutions we have. So all we have to do to figure out how many and what type of solutions we have is to calculate b squared minus 4ac, the stuff underneath the radical. Okay, so here's our first example with the discriminant. Suppose I give you negative 2x squared minus 3x plus 5, and it's equal to 0. This looks similar to the standard form, right? ax squared plus bx plus c. And sometimes I like to write those things above or below. And that helps me identify what the values of a, b, and c are. If you have a hard time like getting the signs right, sometimes a good idea is to like write that out off to the side. So that a is negative 2, b is negative 3, and c is 5. Okay, so some people might like to do that. But I'm asking you here, could you list the number and the type of solution? So do you have two solutions or one solution? And are they real or imaginary? Are basically the two questions that you would want to ask. To figure that out, you're going to use the discriminant. So the discriminant, our Peppa Pig notation is red triangle, is b squared minus 4ac. And then we're just going to take these values and plug that in and calculate the actual discriminant. So b squared, that would be negative 3 squared, minus 4 times negative 2 times 5. And I'm pulling those values from the side where I've listed out my A, B, and C. Notice that my use of parentheses in the very beginning is really important if I'm going to use a calculator. So that if you type negative 3 squared into the calculator, you must include the parentheses. Because you know that negative 3 times negative 3 will be what type of 9? A positive 9. Whenever you do that b squared, it will always be a positive number. If you type this into your calculator without parentheses, your calculator is going to square the 3 and put the negative in front and call it negative 9. So you have to be really careful if you're using your calculator there. For the next piece, I always consider this to be a negative 4 if I'm doing this in my head. So I say negative 4 times negative 2 is positive 40, or sorry, positive 8, I'm thinking ahead. And then positive 8 times 5 is positive 40. So that will be 9 plus 40, which means my discriminant is 49. Now, how many and what type of solutions will I have? 2 real solutions, because 49 is a positive number, right? And if you look back to our last set of notes, it says if the triangle comes out to be positive, which this is positive 49, you will then have 2 real solutions. And so that's your answer, 2 real solutions. And you're done. So that one we're not actually solving. We're not actually doing the full quadratic formula. If we just want to figure out are my solutions real or imaginary, just doing b squared minus 4ac will do the trick. Because we now know we can take the square root of a positive and we'll get 2 answers. Okay. Is everybody okay with that? Does anyone have any questions about what I did right there? Okay, so I'm going to skip the next 2 examples with the discriminant because I think you could probably do that. There's like 2 examples at the beginning of your homework. I think you can do that. Just do b squared minus 4ac and then look in your notes for if it's positive, negative, or 0. And we're going to talk about breaking up the quadratic formula. Okay, so you already have the quadratic formula written down in your notes as that whole piece over there. And you can learn the whole quadratic formula. A good way to remember it, of course, is to sing our song. But when we calculate the quadratic formula, sometimes all those operations in the formula can be a lot to do at once. So we're going to break it up into 2 steps. And remember, this is our Peppa Pig notation. Our first step is going to be to take the discriminant, which is our red triangle, and just calculate that b squared minus 4ac. So that's step 1. And you guys already know how to do step 1. We just did an example. Identify your A, B, and C and plug them in and see what you get. After this step, you'll know how many and what type of solutions you'll have. You don't usually have to list all of those things if you're trying to solve. But step 2 is then to just plug that in. So notice from the top, instead of having all that stuff at once, I've simplified it. So now in my final quadratic formula, I just have to do the opposite of b plus or minus the square root of our discriminant all over 2a. And this formula looks a lot nicer. It looks like a lot less work than the original formula when we have the discriminant included with the b squared minus 4ac. So I've taught students before how to do it by breaking it up into steps. I've just never used our notation that we're going to call red triangle the discriminant. Okay, so we would always talk about the discriminant, the discriminant, the discriminant. And I think that was kind of like this mysterious thing to students. What was I saying when I said discriminant? So we're replacing it with a symbol. Okay, but like I said, you could choose any symbol you wanted. So you can write down this equation. Solve using the quadratic formula f of x equals x squared plus 4x plus 1. You don't have to rewrite the quadratic formula because you should have it in your notes somewhere. And we are going to do the whole quadratic formula. So I left it up there in its entirety. We're just going to break it up into steps. So you are doing the quadratic formula. You're just not doing it all at once. Okay, so that you can make sure that you get the right answer. Okay. One thing I always like to do when I'm a beginner with quadratic formula is, of course, write the ax squared plus bx plus c right underneath it. So I'm going to do that again. And I'm going to say ax squared plus bx plus c. And then figure out what my a, b, and c are. What is a if there's nothing in front of x squared? It must be a 1. Okay, so we can go ahead and say that a is equal to 1, b is equal to 4, and c is equal to 1. So that's helpful. I know what all those coefficients are. Note that when you're doing quadratic formula, you should never be plugging in x's or x squareds into the quadratic formula. It should be only numbers. Okay, okay, so we're going to do step 1, which is to calculate our discriminant, which we're going to use the notation of the red triangle. And we're going to do b squared minus 4ac. So that would be 4 squared minus 4 times 1 times 1. You can use a calculator to help you, or you can evaluate this just kind of on your own with PEMDAS. 4 squared will be 16, and then minus 4 is 12. So we have our discriminant. I can tell that because it's a positive 12, I'm going to have 2 real solutions to my answer, to my quadratic equation. And then I'm going to do step 2, which is to actually plug into the quadratic formula, which is x equals negative b plus or minus the square root of our discriminant, and we'll use our symbol there, red triangle, divided by 2a. And so to finish this second step, I really need to pull out like what's the opposite of b, plug in for a, and then I can just put 12 in where the discriminant is. Okay, so I'm cutting out some of that work from the full quadratic formula. So the opposite of b is negative 4, because it was a positive. And then I'll have plus or minus the square root of 12. And then I'll divide by 2 times 1, which that will simplify to be just 2. So I'm going to go ahead and erase that and call that 2. Okay. Now, here's the place where a lot of people can make a small mistake. A lot of people will look at that and say, oh, hey, all of those are even numbers, so I'll divide them all by 2. Why can you not divide it by 2 right now, Damon? Yeah, one of them's trapped inside the radical, so you're not allowed to do like division right away. There is something you should do, though. Okay? You should come to this square root of 12, whatever your square root is, and then you should check to see if you can simplify it. So like separately, off to the side, you're going to see if you can simplify the square root of 12. Okay? And some of you might use the factor tree, others of you might look for perfect square factors. I'm going to do the factor tree here. That's 4 and 3, 2 and 2. Do I have any doubles? Yes. So I'll be able to rewrite the square root of 12 in the formula. And I'll get something like negative 4 plus or minus. And I have my 2's as a double, so it'll be 2 on the outside. And then the 3 is single, so it's going to stay on the inside. Then divide that by 2. Can you now simplify everything by a factor of 2? All the numbers that are on the outside of the radical, you can. If all 3 numbers share a common factor, you could reduce them. Okay. So these will all reduce by a factor of 2. I'm just going to divide each one by 2. And I'll get something like negative 2 plus or minus the square root of 3. These 2's will both become 1's, which I don't really have to write. Now, that answer looks similar to an answer we would have gotten yesterday by completing the square. And we very well could have gone through the steps of completing the square, but we just put it into the quadratic formula. Tomorrow, we'll do some work with like comparing why we might want to complete the square or why we might want to do quadratic formula. Like what's the benefit of one over another. Does anybody have any questions about my work that's up on the board? Where a number came from, why I did what I did? Yes, Jackson?
So you can't simplify them, the answer is 50.
Yeah, if you could not simplify the square root, so I'll just make up an example. Like let's say you go through the quadratic formula and you get something like 5 plus or minus the square root of 31 over 3. Can't do anything. Okay, so you just leave it alone. The square root of 31, that's a prime number, is not going to reduce. Okay. So sometimes I actually think that's kind of nice sometimes when you can't do anything because you're like, oh, I'm done. And then other times you got to check that radical because you might need to simplify it. Okay, I want to give you one to practice, okay, on your own. So I'm going to give it to you and then I'll walk around the room and kind of see how you're doing. Okay, so this one is f of x equals x squared minus x minus 6. So go through, figure out what your a, b, and c are, and then work through the 2 steps. And I'll come around and answer questions for you as you're working. That we're doing. But there's a couple of things to be very careful about. If any of your terms in your original ax squared plus bx plus c are negative, or they look like minus, that means that when you label your values for A, B, and C, those are going to be negative values for the coefficients. So A is a positive 1, B is a negative 1, and C is a negative 6. So anytime it doesn't look like plus in the standard form, you have to include the negative as the value of A, B, or C. Okay. Then we're going to calculate step 1, which is our discriminant. And we would do something like b squared, which in this case will be negative 1 squared, minus 4 times 1 times negative 6. That's minus 4ac. With this negative 1 squared, when you square this number, it's always going to be positive, so we get a positive 1. And then you just have to be really careful with your multiplication here. Negative 4 times 1 is negative 4. Negative 4 times negative 6 is now a positive 24. So this should be 1 plus 24, which is 25. Okay. So if you got negative 23, that means that you are missing that negative sign. Okay, so be careful with that negative 4ac. If one of A or C is negative, then it will really be a plus. If they're both positive or they're both negative, it will stay negative. Then we'll plug it into our quadratic formula and check this. When you start the quadratic formula, it should be the opposite of B. So if B was originally negative 1, when I put it in, it will be positive 1, right? So change the sign. 1 plus or minus the square root of 25 all over 2 times 1. That's 1 plus or minus, what is the square root of 25? 5. And notice how I write it without the square root over it. So once you take the square root goes away. And then it's being divided by 2. And now you have no radical in your answer. So you actually want to simplify and combine these as like terms, but you have to do them 2 separate ones. Okay? So one of your answers is 1 plus 5 divided by 2. And the other answer is 1 minus 5 divided by 2. And so that gets me 6 over 2, which is 3, and negative 4 over 2, which is, negative 2. So my answers for this are positive 3 and negative 2. And those answers look a lot nicer than 1 plus or minus 5 over 2, right? So we want to actually simplify them. When your quadratic formula comes out to be like nice numbers like this, or a perfect square for a discriminant, this is the same as yesterday when we had Grumpy Cat in our notes. It means we could have just done what? We could have just factored this. If you look up at the top, do you have factors in negative 6 that add to make negative 1? Negative 3 and 2. And then if you factored out as x minus 3 and x plus 2, you'd get the same 2 answers, positive 3 and negative 2 when you set them equal to 0. So that's kind of one of those Grumpy Cat moments where you're like, oh man, I did all that work and I could have just factored it. So that's why we'll talk about tomorrow too. Always check first to see if you could factor, because that's probably the easier route, and most people would probably choose the easier route if they could. So kind of be aware of that. Any questions about where those values came